This is homework page 176, 25, 27, etc. Okay, 25, we want to use the vertex formula, which is negative b over 2a. This helps find the x of our vertex, which in this case is negative, and our b is negative 10 over 2 times our a, which is 1. Okay, so that makes 10 over 2, which is 5. Okay, that finds the x of our vertex. Now to find the y of the vertex, I can take this 5 and plug it in. So 5 times 5 is 25, 10 times 5 is 50, 25 minus 50 is negative 25, plus 21 would be negative 4. So we found our vertex. And then just draw a little sketch there for part B. We want to make a table of values here. And we have 5, negative 4. We got to find values below, so 4 and 3 and 6 and 7. And we got to take those numbers and plug them in. Okay, and when you plug you can do this two ways. You can do it in Desmos like I show you in class, or you can take these 4 and plug it in here. When I plug in the 4, I get negative 3. When I plug in the 6 in there, I get negative 3 as well. When I plug the 3 in there, I get 0. And plug the 7 in there, I get 0 as well. So when I sketch this then, so I know 7, 0, and 3, 0, 4, negative 3, and that's negative 3, and 5, negative 4. So we can get a good idea of what our graph looks like. Okay, number 27. Okay, so once again, we're going to use negative b over 2a, so negative b over 2 times a is negative 1. So this would be negative 4 over negative 2, which is 2. Take 2 and plug it in here. 2 squared is 4. So negative 4. 2 times 4 is 8. Negative 4 plus 8 is 4. Minus 2 is 2. So I know my vertex is at 2, 2. Okay, part B, draw the graph then. We're going to make a table of values. 2, 2 is in the middle of that graph. Pick two numbers below, like here, right? 5 was right there in the middle. We used 4 and 3. We also used 5, 6, and 7. Okay, so above, let's use 3 and 4 and 1 and 0. Okay, and when you find those values, I'm going to use calculator here, but you can use whatever you'd like. Desmos is good, or plug it in, use your head, which is always good. Plus 4x minus 2. Okay, so at 1 it's 1, 0 is negative 2, 3 is 1, and 4 is negative 2. So we have some points here to plot. 0, negative 2, 1, 1, 2, 2, 3, 1, and 4, negative 2. So you can see that graph there. Number 29, negative b over 2a is negative 4 over 4, which is negative 1. Okay, so I'm going to use my calculator again. Use Desmos if you have it, if you want to, or plug it in yourself. Okay, at negative 1, x squared minus 4x plus 5. Oh, I messed up. The b is a negative 4. So negative 4 makes that a positive 4, which makes that a positive 1. Okay, that makes more sense. So it's the 0.13. If you plug the 1 back in there, you get 3. Making your table. 1, 3 is in the middle of our graph here. So let's use 2 and 3 and 0 and negative 1. Just numbers right next to them. At negative 1 we have 11, 0 is 5, 5 and 11. Okay, so we can get a real nice look at what that graph looks like. Okay. Okay, so 41 asks us to look at this graph and says, what is the minimum value for f of x? So the y, what's the minimum value for the y? So the y, the lowest value is 3. For 42, for what value of x does f of x assume its minimum value? So what is the x when we have our minimum? So this is our minimum value, and our x at that point is -3. 43, how many real solutions are there to f of x equals 1? So if this is x equals 1 here, right? Okay. Does it ever intercept x equals 1? Does this ever come down and equal 1? No. The lowest value is 3, right? It'll never come down at 1. So there is none. Where is it equal to 3? Okay, so here's 3. At how many points is it equal to 3? Just this one, at x equals -3. So just 1. Okay, number 55. Okay, with 55, okay, we can kind of think about, it says an athlete's heart rate in beats per minute is given by this equation here. So let's kind of get a graph of what this looks like. We know that it goes up to 90. That's our, and it also goes right 4. And 2 means it's going to open up like this. Okay, so the graph looks something like that. So from 0 to 8, so from 0 to 8, what is happening? Well, heart rate is decreasing, and then it's increasing. Okay, so it decreases up to 4 minutes. Then increases after 4 minutes. Okay. Part B, determine the minimum heart rate during this period. Okay. So the minimum, like this is our heart rate. So at 4 minutes, the minimum is at 90. So 90 beats per minute at 4 minutes. Okay. 56. Graph shows how Social Security assets are expected to change as the number of retirees. So more people, as more people retire, there's going to be less and less money there for people to, because more money is going out to other people. So anyway, it suggests it's a quadratic function, and this is that quadratic function. So part A, okay, so x equals 10 represents 2010, 15 would be 2015, etc. So this is 20, 25, 30, and 35. Explain why the coefficient of x squared is a negative based on the graph, okay? So if you think about this, it's opening down, right? So part A, the parabola, it's opening down, so therefore I know it's going to be a negative x squared there. Okay, so since it's opening down, it's going to be a negative x squared. Part B, determine the vertex of the graph. Okay, so the vertex, once again, we learned today, we use negative b over 2a. So we use negative 431.8 over 2 times negative 10.36. Okay, and if you work that out, it's going to come out to be about 20.84. Okay. Now, 20.84 would be, around here, right? Okay. So not quite year 2021, but 2020. We should be at the peak, okay, of the assets. And to find the peak, what that peak is, you take this value, plug it in here for these x's, and you should get about 3849. Okay? And this is in billions of dollars. So the peak should be about right now, according to this model, right now in our history, right? 2020, at the end of 2020, there should be that many billions of dollars in there. So $3,849 billion of assets in Social Security. Okay, interpret the answer to part B as it relates to the application. Okay, so it'll have its highest assets, which is $3.849 billion in 2020. Okay, towards the end of 2020. Okay, that's 56. 57. Okay, so here, heart rate of an athlete while training is recorded for 4 minutes, and this is the number of, so X is the number of minutes, and this is their heart rate. Okay, so you want to use Desmos for this. So in Desmos, okay, think about that there. So when you look at this, okay, so part A asks us, explain why it's not linear. Okay, so notice the goes up and then it starts going down again. So if you look at your data, it starts to go up and then it starts to come down again. So the y variable goes up and then back down. Okay, so that means it's going to be quadratic. Okay, part B, find the quadratic function that models the data. Okay, this is where I want to use Desmos, y1 tilde ax1 squared plus bx1 plus c. I'm going to plug that into Desmos here. Okay, so using Desmos, I plug this into the numbers into the table, use this, and I get this equation. Now another way to think about this is if you put it in vertex form, you can also think of it in vertex form. So notice the data, the highest point, the vertex, is basically 2 and 120. So the high point would be at 120, so it goes up 120. And the vertex is at 2, to the right 2, which means x minus 2. And then to get that to work out, it comes up that it would be a negative 9 in front there. But I think the easier thing for you to do is to do this part right here. Okay? Okay, part C says what is the domain? Okay, what is the domain of your function? Our domain are our x values, so they go between 0 and 4. Okay, so between 0 and 4. Or if you interval notation, between 0 and 4. Okay. Last one, number 60. A toy rocket is launched from the top of a building 50 feet tall. Okay, so we think about a picture of this. Here's our building, and it's 50 feet tall. Okay, and it's launched off this building at 200 feet per second. Okay, that's how fast it's going. T is the amount of time after the launch. Okay, write the equation down, so you have to go back to your notes to get the equation. But basically, S of x is equal to negative 16 t squared, and then plus the initial velocity, which is 200 feet per second times t, and then plus the initial height. And the initial height was started 50 feet off the ground. So there's part A. Okay, part B. Time at which where it reaches its highest point. So the highest point, okay, so if you think about this, then we're going to have time and height. So it starts at 50 feet, right? And it's going to go up in the air for a certain amount of time, and then it's going to come back down. So the highest point there is the vertex. So how do we find the vertex? We use negative b over 2a. So we have negative 200 over 2 times a. And 200 divided by 32 gives you 6.25. Okay, so that means after 6.25 seconds, it's at a certain height. Okay, and we want to find what that height is. So we got to take this 6.25 and plug it in here for these t's. Okay, so plugging that in there gives us 675 feet. So we know that the top of it got up to 675 feet after 6¼ seconds. Okay. Part C, when is it more than 300 feet above the ground? Okay, so what we need to do is we need to find the point here where it's equal to 300. So we need to find this time and this time. So we're going to use Desmos to find that out. Okay, so I'm going to type this into Desmos. Actually, I'm going to make a video here about that as well. I'll type that on.
Okay, so here I've typed in the equation, and I want to get a nice window of this. So I know that it's going to go up to, and we found the vertex to be up at 675. So I can go here, I can change my x, and I can change my y. So my x-axis, I don't need to go, 0 is fine, and goes out to, I don't know how far I'm going to have to go out, but I know that the vertex is at 6, so I'm just going to go out to 15 and see what that does. The y-axis, I'm not going to go below 0. Actually, I'm with both of these that show -1, just so you can see the axis. Right, and the y-axis, then, I know it goes up to 675. I'm going to go to 680 so we can see it. Okay, so here we see a good graph of this. Okay, so you can see it starts here at 50. Okay, that's the building that it flies off of, and it flies up into the air, gets a maximum height here at 6.25, and, well, at 6.25 seconds, the max height is 675. And then you can see this starts coming back down. Now, we want to know for part C, how long is it above the y is equal to 300? Okay, so here's 300, and it's at 300 at 1.409 seconds until 11.091 seconds. So the exact question says, for what time interval will the rocket be more than 300 feet above the ground? So for how long? So from here to here, from 11.091 seconds minus 1.409 seconds, it will be above 300 feet for 9.682 seconds. Okay, so if I subtract those two times. Okay. Next, part D says, after how many seconds will the rocket hit the ground? Okay, so by looking at this, it'll hit the ground when our height, right, our height is the y, when our height is at 0. So it'll hit the ground right here. Okay, so after 12.745 seconds, it will hit the ground. Okay, and that is the end of the homework.